we're going to learn about related rates. Yay! Using this super fun practice problem. Because the best way to learn is just to practice it, learn it, and do it. So here we've got 30-foot ladder leaning against a house. The base of the ladder is being pulled away from the house at a rate of 3 feet per second. How fast is the angle that's made between the wall of the house and the ladder changing when the ladder is 24 feet from the house? So what we're going to do to start is draw a picture. Here we've got the 30-foot ladder leaning against the house. We've got the angle between the 30-foot ladder and the wall of the house. We've got the ground, and we've got your rate that the ladder is being pulled away, 3 feet per second. So what we're looking for is the rate of change of this. But since it's a rate of change, you're going to have to find it at a particular snapshot value is what we call that. And that snapshot is going to be at 24 feet. Now, even though we have two values for this triangle, we could find the third side, but since it's constantly changing, that is only one triangle out of many. So we're not going to do that. Not yet. First, we're going to use sine theta because we've got an angle, we've got the opposite side right here, and we've got a hypotenuse. So we're going to have sine theta is equal to x over 30, 30 being the ladder. So what we're going to do is take the derivative of this, but it's going to be a little bit different because this is a related rate. Since this is a rate, we're going to be taking the derivative with respect to time, and that is going to look like d dt. And the way this works is if there's no t in this equation here, then you're going to have to put these different variables into the ddt. So what you've got is derivative of sine is cosine theta d theta dt. See how there's no t? Theta goes into the ddt because it's derivative with respect to time. So now what I did here is I just made this 1 over 30x, then used that for derivative instead. So I've got 1 over 30 dx dt, because again, x is not t. So now we've got this fun little looking problem. What are we going to do with it? Well, I'm glad you asked. Now that we've taken the derivative already, and we know that it's going to be a snapshot, we can use the Pythagorean theorem to find cosine theta. Yay! So we know x, we know hypotenuse. We're going to do 30 squared equals 24 squared plus y squared. Y is going to come out to be 18. And y is what we need for cosine in this instance. Got our adjacent angle right here, our adjacent side, our angle, and our hypotenuse. So that's going to be, the cosine theta is going to be 18 over 30. And you still got your d theta dt. Now we've got 1 over 30 still over here, and we actually know what dx dt is also. That is going to be this right here, 3 feet per second, because 3 feet is your x, it's how much it's moving, per second with respect to time. So 3 feet per second. Now how do we want to solve this? Oh, I don't know, let's multiply by 30 over 18. look at that. Things cancel. So 18, 30, 30. That leaves d theta dt all by itself. Got 30 and 30. So now we've got d theta dt equals 3 over 18, which is going to be 1 over 6 radians per second. Because don't forget, this is an angle measure. It's the rate of change of the angle, how fast it's leaving the house. Or actually, it's how fast it's changing when the ladder's leaving the house. So there you go. And that is related rates. Good job, yay!